the gear shaft of this excavator in front of us, due to its old age, broke into two sections after working continuously for 72 hours under extreme pressure. Replacing it with a new one would cost 25,000 rupees, but the repair shop offered to restore the broken gear shaft to factory condition for just 2,000 rupees. The owner didn't hesitate to choose the latter option. Given how severely this gear shaft is broken, it's clear that glue won't hold it together. The craftsman plans to repair it by welding, but direct welding might not meet the strength requirements. So, before the repair, the craftsman first measures the original length of the gear shaft to calculate the required size for the joint. He then selects a half axle of similar hardness for the splice, which not only restores the original length of the gear shaft, but also ensures the overall strength remains unaffected. After marking the measurements, the craftsman fixes the flywheel end to the lathe chuck and uses a lathe tool to smooth out the broken surface. Considering the upcoming splicing, he trims the shaft, but only by about 1/3. Throughout the process, the craftsman uses a micrometer to measure, recording the shaft's dimensions to ensure precision when processing the remaining sections. Once the flywheel end is finished, the craftsman moves on to the other end of the shaft. Since they've decided to use steel for the splice, the other end of the shaft also needs trimming. This step is similar to the process for the flywheel end, simply cutting off the excess part. Once the other end is done, the craftsman begins preparing the cylinder for the joint. First, he smooths out the surface of the cylinder. Since the center of the gear shaft has a borehole, the craftsman uses a small drill to make a through hole in the cylinder. He then uses a larger drill to expand the hole, ensuring that the inner diameter matches the pre-existing dimensions of the gear shaft. To make the inner wall of the hole smoother, he removes any roughness that could affect the precision of the joint. Throughout this process, the craftsman frequently stops to measure with calipers and micrometers to ensure accuracy. After multiple adjustments and precise measurements, the cylinder reaches the required standard and the components are ready to be joined. Since the machine measurements are extremely precise, it's difficult to fit the parts together, and the craftsman has to apply significant force. However, the other end of the shaft proves even more challenging, requiring the use of a hydraulic press to apply enough pressure to force the parts together. Judging by how tightly the parts fit, the shaft could function even without welding for a time. With the three sections of the shaft now forming a solid unit, the craftsman needs to create bevels at the joints to increase the welding area. After machining the required bevels, the craftsman performs a full weld on the cracks. To ensure the weld quality, he pauses after each layer to hammer off the slag, preventing any impurities from forming in the weld. Once the welding is complete, the craftsman grinds down the raised weld beads to make the area smooth and visually appealing. Finally, he uses sandpaper to meticulously polish the entire surface of the shaft, removing all uneven spots and excess weld material. And so, through precise welding and machining, a gear shaft that was once broken in two has been fully restored. What do you think of the craftsman's skill now?